Hello everyone, welcome once again to another Power BI tutorial. In this part, we are trying to analyze delivery or logistics data. The data set that we have got is from Kaggle. I will explain about the data set. You have to understand it in great detail. But in this dashboard, currently we have information of total shipments, total distance covered, average delivery time, on-time delivery percentage that we will calculate with DAX, delayed shipment percentage. We will also see how we can create day of week and how we can see the total values here. You know, how we can create this type of metric or heat map. We also have different filters like route type, full truckload or carting type of filter. You will see effect of these filters on different visuals. We will see that OSRM versus actual time, what does that mean, and OSRM versus actual distance, and date wise different routes. All of this will be discussed in this data set and it has a lot to understand. So let's get started with it. So the data set that we are trying to visualize today is delivery logistics data set. The data set can be obtained from this Kaggle URL, and this dataset focuses on deliveries operations, providing detailed information about trips and deliveries. It includes data from both testing and training phases. So when you will download the CSV file or Excel file, you will see in your data you have a simple categorical column representing data as either a test data or a training data. We have a trip creation time, route, schedule, UUID, some kind of ID for the route schedule. What type of route is it? Is it a carting route or a FTL route? So full truckload can be FTL. Then we have trip UID. So for every trip there is a unique ID. Source center from where the parcel are picked. Source name, destination center and destination name. We have OD start time and OD end time, which is simply trip start time and trip end time. We have a start scan to end scan. So in this data set, the start scan to end scan field typically represents the time duration in seconds, minutes or any other unit between the first scan of package at a logistics faculty start scan and its last scan at the same or subsequent facility, that is end scan. And this metric is often used to measure processing or handling time when a logistic network or within a logistic network, and it can help analyze operational efficiency, identify delays and optimize workflows. The next field that we have is cutoff field, and it indicates whether a package was processed before or after the cutoff time for dispatch. 1 or true typically means the package was processed before the cutoff time, and 0 means it was processed after the cutoff time. And this information is crucial for tracking whether a package was handled within the expected timelines. The remaining columns are cutoff factor, a factor representing the impact of cutoff time on the delivery process, often used to assess whether cutoff times are met. So here you will see some cutoff factor value. Then we have segment actual time. So we also have cutoff timestamp, the timestamp indicating the cutoff time for a package, which is the deadline for processing. Actual distance to destination, the real physical distance from the current location to the destination. This is actual destination. Then we have actual time, OSRM time. So obviously it is very useful because it gives the estimated time to the destination based on open source routing machine, a routing algorithm used for estimating travel times. We have OSRM distance, the distance from the current location to the destination based on OSRM estimates. Factor is a factor indicating performance or efficiency, often comparing actual result to expected ones. So you have that particular factor, and we have segment actual time, segment OSRM time. So this is different because the actual time taken for a specific segment of the journey and the estimated time for a specific segment based on OSRM, the machine or algorithm that we talked about. And we also have the segment OSRM distance, the estimated distance for segment based on OSRM, and some factor which is a factor comparing the actual segment time or distance to the OSRM estimated values for that segment. And these fields are typically used to assess and analyze the efficiency, accuracy, and performance of our delivery process and routing. Obviously, when we will start creating our visuals, then we will explain these values, in more detail, and trying to understand, because there are many columns. So understanding them is very, very crucial. Then only you can start the exploratory data analysis process. So here we have Power BI. We have simply connected the data with Excel connector and just loaded the data. In order to begin the exploratory data analysis process, we start with building some KPIs first. That always helps us in exploring data further. First, we will build the KPI for total shipments. For that, we will simply use a card visual here. So here is our data pane visualization. Here is our area which is a report view. This is a table view where you can see all columns, and here is the model view. In this case, we don't have any other table yet, so we will simply start using and building visuals here. Just use card, and now let's reposition and resize our card because we will put various KPI fields here. And after repositioning, we will simply bring a field here. So the field that we want to analyze is total shipments. So we can do it by using the trip UUID, which is the unique ID for trip. So if you will simply drag it to fields, you can simply use count distinct, and this will tell you this is count of trip UUID, which is nothing but the unique identifier for that trip. Suppose you want to do the similar thing with the help of a DAX function. For that, we can go to the modeling tab, and from here we can try to create a new measure. And here we will use a simple measure name. So measure name we are using is total shipments, and we are using the formula count rows, and delivery is the name of this table. And we will simply check it. Now we will see this particular measure total shipment has been created. So count rows will simply count total number of rows in a table. This is our table name. And if we drag a card here, in that card, if you will bring that, so you will see it is showing us a summarized version of the same thing. We can go call out value. Display unit is auto, we can say none. So it will give us the exact value. And here also, if you will say none, it will give you the exact value. So it is showing 14,817 rows, and it is showing 1,44,867 rows. And that is because here we have selected count of trip ID, count distinct. If you will use count, that is total number of rows, then it will show this value, right? So always make sure what you have to display. If you want to display the unique count of trips, then obviously you will always choose count distinct. Okay. To fix that, once again go to your measure and use a formula called distinct count. In distinct count, you have to select a column. The column, first write the name of the table, then in a square bracket write the name of column, so which is strip UUID, and when you will simply check it, it will come as the same value. So whatever you are doing, make sure you are using the right type of formula to calculate that value. And our purpose to bring these tutorials is to teach students about these different type of DAX functions. In the playlist itself, you will find many such DAX related queries, many DAX related expressions that we have taught. So you can go through them and learn. So you can keep any one of them. Obviously, we can keep this also because this is simply showing the term that we want to show, total shipments. Now, this is the category label that we are seeing. Anytime when I will click a measure, I will go to format your visuals, and in format your visuals, you will see a visual setting and a general setting. In visual setting, obviously whatever you are seeing here, you have a call out value, this big value here. So you can use auto here, so it will show 15,000. It will kind of summarize the data. If you want to change its color, so you can use a different type of color for it. So let's say we want to choose this color, okay, or whatever color scheme you want to choose, you can select from here. Now we have selected this, and you can see in your category label the value is still dark. You can make it bold, and you can select a different type of color for it. From here you can increase the size, from here you can decrease this size. Okay, this is one way of showing the data. Now here when you select a card, you go to its format, you go to general tab, you have a title. You can enable a title and write something there also. Let's say total shipment. Now your title will appear like this. You can make or align it to center, make it bold, increase its size also. So whatever you prefer, like if you want to show it on top, you can use title. If you want to show it in bottom, you can keep using the visual or label. So we will disable the label. Now we have option to, you know, reduce the gap and reduce overall size. And here we will go once again. In title, I will use a different color. I will use this color. Okay. So this is our total shipment. In format visual general tab, we also have effects, which I have taught many times. In effect, we have a visual border, a shadow. We can select a visual border as per our theme. We can make the corners round, and now our card will appear more highlighted, right? So this is optional, but you can do that. To build your KPIs, you can simply copy your visual. So press Ctrl C, Ctrl V in Windows computer and copy and paste command as per your computer's configuration. For example, in Mac, it can be Command C and Command V. So we can create different copies, and in these different copies, we can bring the different visuals. The next field that we will try to create is average delivery time taken for each trip. So in the data set, we have a field called actual time. Okay, this is the field actual time. Obviously, when I will select this and sum this, this will show us overall, sum of actual time. But we want to bring or build the average delivery time. So what we can do here, we can go to modeling tab, or suppose we don't want to create that. I showed you one way of creating it, but I can go to a search here, actual time. So I have actual time here, and I will remove from the second visual and bring actual time here. It will show 60 million, which is sum. So always choose that aggregate function that you want to show, average time. Okay, this is now average actual time for shipments. And from our understanding and based on OSRM time, etc., this time appears to be in minutes. Now this is now total shipment is written there. So we will simply write average trip time, and we actually have it here. So I will simply copy as average delivery time. Obviously, I can see that when our heading will be longer, so we will need more space here. So I will adjust accordingly. But first we will build some visuals and then adjust their height and width. Next, we will try to find out on time deliveries percentage. There is a field called is cutoff. In is cutoff, 1 means on time and 0 means delayed. So we will use the DAX formula. You can copy the code. So we will simply go to modeling tab and create a new measure here. So on time delivery percentage is the name of this field. We are using the divide function. In divide function, we provide the first value, that is what to divide by which value. So obviously we are dividing it by total shipments that we created earlier. So we created total shipments, right? And on the basis of total shipment, we have the information of how many total shipments are there. And here we are using count rows filter. And in filter, you first select your table name, and in your table name you select what is the column that you want to select and its value. So we are saying delivery is cutoff is equal to true. Okay, because in our data set is cutoff is given as either true or false, and its format is also shown as true or false. So make sure it is appearing as a boolean format here, and this way we will be able to create on time deliveries percentage. Now remember, total shipment that this particular thing will look for is total number of rows. So count rows that we created earlier. So here I will simply try to replace it with count rows of table. Now we write 0 because in the divide function you have numerator and denominator. So denominator will be total number of rows and numerator will be total number of rows with filter where cutoff is equal to true. So count those rows where filter is equal to true, where is cutoff is equal to true, divided by total number of rows, and divide by 0 case. We write 0 just to avoid any error, and we will simply multiply it by 100 to make it as a percentage. Now we will simply click here and we will bring on time delivery percentage. So it is showing as 81.97 deliveries are on time, right? And here we will simply copy this name and we will write it here. So this is on time delivery percentage. It is a 81.97% of deliveries are on time. Again, whatever information we are getting here is from the data set. This data set may be just for sample or educational purpose, but if you are doing analysis for any logistic or delivery company, this type of DAX, this type of calculations and exploratory analysis can be done. Now, one more thing is either you can keep it written like this, or when you are clicking a measure here, when you will click that, its format will appear as general. Here you can select percentage. So when you will select percentage, it will start showing it like a percentage. So in that case, in your measure, for example here, we don't have to multiply it by 100. So we will simply make sure. So now you can see it is shown as a percentage value and we don't have to multiply it by 100. At the end of this session, I will provide all these measures, whatever we are creating here, so that you can also copy and create them and learn from them. Note, as we have created on time, we can also create delayed shipments. I'm just pausing in writing this formula and testing so that when I'm explaining it to you, it will not make too much, it will not take too much time. So in the field, in the same field, if we just write false, right? So in that case, we will get delayed shipment percentage. We'll go to modeling tab once again, new measure, and here we will write delayed shipment percentage. And here I'm going to use it like this. I will just create a copy. After creating the copy, I will select uh, the other measure which we have created, delayed. So I will write delayed here. So delayed shipment, I will remove it from here. And after selecting it, I will also select it as a percentage. So from here, you can specify the format of the data. If you want to display in form of currency or a value with commas as 1,000, so you can select that. So this is on, it is showing 176.27. Seems something is wrong here. Let's see why. And again, the reason is because of the count rows thing, because we have used the distinct count here. So we just have to use distinct count. So we will write it like this. And when you will hit apply, you will see the difference. When you will add them, it should come to 100. So which is now appearing here. And we will simply rename this also. This is delayed shipment percentage. So go to title and rename this delayed shipment percentage, because all the numbers are appearing without any formatting. So I will just enable this number also. So now we have some KPIs. We can also try to build total distance covered. So let's copy and paste. And for first, let's see. So we have actual distance to destination here. So we can use it for total distance covered. When we will bring it, obviously it will be a large number. So we can simply go to call out value and summarize it in millions. Okay, and this is total distance covered. So we will simply change the title total distance covered. Obviously, we are trying our best to make these calculations accurate. If you think we are making any type of mistake here, you can also let us know so that we will correct it and post the corrected version. So here we will simply adjust them, and I will simply pause and adjust it. I can go to insert, I can go to shape and try to bring a shape here. Just showing you a simple way to format. Cover the shape in complete distance here and go to format tab and send it to backward. Send to back. Okay. So this way all our visuals will appear just above this simple ribbon or whatever you want to call it. So this is also one way of displaying your data, and you can select your shape, and in your shape style you can choose a color that you want to choose. Okay, So this is also one way of displaying your visuals, and I will just align it to little center so that we have some left and right margin. And using Canva, I have created a simple truck design here to represent delivery and logistics business, not necessarily the business that we are analyzing here. And we can simply use the image tab to bring it here. So go to insert image and select that image so that we can analyze. And I have used similar kind of color that I was using there to represent it. So this is just to use for reference, not necessarily needed. Now we have created some KPIs here. We will just rename our as delivery delivery data EDA. We can also use text here and delivery data delivery slash logistics data EDA or whatever you want to call it. Select this, align it to center. I will choose this dark blue color and I will choose the font size as 24. 24. Make it bold. I think I can go with 28 and I will simply align it here. This is something that I have done in my previous videos also. So it's not something that we are doing for the first time, but you always have to put some relevant information, right? So that people who are watching the video will also understand what we are doing here. And particularly those people who will use this particular report for exploring the data can understand. I can click here and go to effect, enable some kind of shadow here so that it's it looks kind of highlighted. And this space I will probably use later for putting some filters. Now this particular thing on time deliveries etc that we have shown here. So we have the cutoff timestamp and is cutoff. Okay. In is cutoff we have true or false. We also have the cutoff factor which we will use, but we have true or false. When you have this type of data that is true or false, so you can use a donut chart here, and in the donut chart we will simply bring is cutoff as a legend, so it will automatically bring true and false values for us. And in values we are going to select total number of shipments, so trip UUID, and we are going to use count of trip UUID. We can also use count distinct, so in count distinct case you can see almost 50-50%, and for total number of rows you can see the data like this. Okay, so is cutoff is true in 81.97% of cases and false in 26% of the cases, 18%, sorry. And this is something that we just calculated above. So if you want to display it as a KPI, you have one option there. If you want to display it as a chart, you have your second option here. Here also we will simply copy it, and here also we can go to general tab effects, and we can see we have enabled shadow. So and we want to do the same for here. So just copy this, go to home tab, format painter, and copy the same styling. So now you have the same kind of styling here. Obviously count of trip UUID by is cutoff is not making sense here. So we can simply call it cutoff analysis. So this is nothing but cutoff analysis, and is cutoff is true and false. We can Now you can see earlier we were able to see some data values here. So you can click here, go to format visual, and you can see detail labels are on. Values are also there. So let's reduce their size. Maybe because of this bigger size, we are not able to see them. When you will make their size approximately 9 pixel, then you will be able to see them. And we can go back again, at least make them bold, so they will be visible properly. We can also try to adjust the legend position. This is called legend here, right? So in your data you have legend. You can either turn off, so now you will not know which one is yes or no. That's why legend is important. And you can make it to bottom center. So now your values are also, you know, viewable, and everything is properly visible now. So this is simple cutoff analysis for our delivery data set. And just to make our, visualization a little more interesting, I am going to bring one more image here. So this is the image. Obviously this is not necessary, I'm just using it to show the values in a different way. And here what we can do, we can go to style, use fill. So the size of image that I have used here is 1280 by 720 pixels. I will try to provide this image as a resource if you want. And here now obviously this image is appearing over above our KPIs. So what I am going to do, select this image and go to format and send backward, right? And send backward, send to back maybe. Just a minute. So we have actually sent it to back. And here what we can do, we can just shift it down. Again, we are probably shifting from our main focus here, but I just want to show you different formatting styles. And if you like, you can use them anytime, right? So we have this image, and this is a transparent image. So when you use transparent image, you can see, you can put them behind different elements and create your visualizations. Now we can put some visuals here on this side, on this side, on this side, and that will make our logistic data interesting. Visually, uh, the main value will come when you will put valuable insights here. Next, we will try to find out day of weeks and hours of day. Sorry for that. So day of week and hours of day. For that, if you will go here, you will see start time, end time is given. We also have a time stamp, okay, for cutoff. So cutoff time stamp, because we are doing the cutoff analysis here. So in cutoff time stamp, you have a value, okay. In that actual data set, a time stamp is given like this, okay. So from this, day and hour, how we can calculate. So for day of week, we will use format, use cutoff time stamp, and use 4 times D here. Okay. So this will simply give, because we are writing D here, so it will simply give us day of week. So we will simply go to our visual modeling. From here we will create new column, a calculated column in the same table, and we will call it day of week. In a similar way, we will again go to new column and create R. So here instead of format we are using R. So with the help of R function, we can simply get the R of day. So now we have R of day and cutoff time stamp. Now after finding out day of week and hours of day, we will try to create a matrix of cutoff compliance by day and time. For that, we already have the percentage value like that we created on time deliveries. So what I'm going to do here, I will use matrix here, and in the matrix we will simply first we have to align the matrix properly. So whatever size you have to align, and this is cutoff compliance. Now in the matrix in rows we will use day of week. So for Friday, Saturday, Sunday, Monday, every day of week we want to see on time deliveries. And in columns we will use hours of day. So from 0 to 24 hours we have 23 obviously here. And in values we can bring something like on time deliveries. So this is a simple matrix. Okay. Now in the matrix here we can go to format your visual. In the value section you have options to change the value colors, etc. But here we to enable some kind of heat map like effect for our matrix, right? We can go to cell element. In cell element there is a background color option which can be used as a function. Just turn it on. So you will have some kind of you know heat map kind of effect here, and obviously to see it properly, because there are so many days, you can show it like this. So in your exact data set you can show it, but we will just create a simple summary of this, and someone wants to see they can see. Why is it helpful? Because it will like, help you in understanding dark areas where you can see on what days and what day of week we have darker shades of blue here. Okay, so for example here we can see 94% Sunday, 94%, maybe because of less traffic. So and whatever factors you can imagine, you can obviously experts can get more features, but this will help you in understanding the cutoff compliance by day of week and hours of day. And maybe I was wrong, this is not day of month, this is hours of day. So on Sunday around 1 p.m. you can see we have the highest value that I can look at, and we will simply use proper title here, which is cutoff compliance by day and time. And I'm not going to use copy format painter. I will just make it bold, align it center, and use color here. If I want, I can simply enable the shadow effect that I was using. Otherwise, I can leave everything as it is. Next, we have to do time and distance insights also. We have to look at this. So the type of charts that I can suggest you is a scatter plot comparing actual time versus OSRM time. When you have two numerical continuous values, you can always use a scatter plot to compare them. Like for example, if actual time increases, what is effect on OSRM time? So OSRM is a routing service based on OpenStreetMap data, and you can go to this URL for more details. This package enables the computation of routes, trips, isochrones and travel distances if you are using R package. So, and as I explained earlier, the estimated time to the destination, okay, based on OSRM, open source routing machine, and a routing algorithm that is used for estimating travel time. In R, OSRM can be used as this, but uh, here you can say the estimated time to destination based on open source routing machine. So we will use scatter plot comparison between actual time and OSRM time. So we will see that you know if what is the machine predicted time and what is the actual time and what is the relationship between them. So here we will use a scatter plot, and you can place a scatter plot anywhere. Obviously, we have used this. It is not necessary that you also use this if you want to put more visuals here. And I also suggest that when you have created your visuals, then you can bring this type of background images. Here we will simply select the data, and first we have to bring x-axis and y-axis. So we will bring OSRM time on the x-axis and the actual time that we got on the y-axis. It will show you sum of values because by default this also summarizes the data, but for every record if you want to see you can say don't summarize. So this is OSRM time and this is sum of actual time, so we will say don't summarize this as well. And now you can see a linear trend that when OSRM time is increasing, actual time is also increasing. So we can predict some kind of linear trend here. And here, if you want to put for further analysis, enable a trend line here to show the trend data. You can choose a different type of color for your trend analysis. Let me choose something that will be properly visible. You can also make it dashed, and whatever you want to do you can use more styling. I will simply select this and go to home and format painter. So this is OSRM time and actual time. We will write something like OSRM versus actual time. Here you have your visual options where you can enable or disable x-axis and y-axis if you want. X-axis labels and y-axis labels, for example title and value. If you want to disable them, it's your choice. And in y-axis also you can enable or disable them. So this way your chart will get more area. So it's your choice. So we will enable title and disable values properly. One of them we can disable. This is OSRM versus actual time. Similarly, you can also create a scatter plot comparing actual distance to destination versus OSRM distance. So the just like time, open source routing machine time. So its distance will also be there. So actual distance covered may be different from some estimated distance. And you can also create a histogram of start scan to end scan. So which is the distance in minute from start scan to end scan, and this will show the processing time distribution. But before that, I am just putting one more plot here. Compare the number of trips by route time. So we have carting versus FTL, the full truckload. Let's say how many number of trips do we have for carting and how many number of trips do we have for full truckload. So as per some quick research, route time could refer to carting or FTL, which is full truckload. Depending upon context of operation, carting refers to smaller scale transportation, typically involving local movement of goods. This could be transporting shipment from a warehouse to nearby distribution center, involving smaller vehicles or partial loads. In route time context, if the time tracked is for local deliveries or partial loads, it's likely fall under carting. And full truckload refer to transportation of goods in a fully loaded truck from one point to another. And if the time is for a longer haul delivery. So First of all, we'll see how many number of delivery or how many number of shipments do we have for each type. For that, we can simply use a stacked column chart, and we'll bring the stacked column chart here. And here, first of all, I am going to make this image smaller, but later I will just adjust it. So here we have this, and first I will use format painter to copy my styling. And here on x-axis and y-axis we have to pick values. So on x-axis we will bring the type here, so the root type, and on y-axis I will bring trip creation or count of trip. This is one way. So count of trip URD, you can see we have more trips of FTL, full truckload, than carting. This is one way. You can also get what is the average actual time for these trips, right? So this is actual time. So you can see some, but we will see average. So in just let's zoom in. So in average, actual time is 574 minutes for full truckload, but for carting the average time is 70. So this kind of confirms that it is a shorter distance uh, route, right? So whatever value you want to put here, you can select accordingly, and let's keep it to average or number of trips. Okay, so this is number of trips by type. In your chart here, we can go to data labels and turn them on, and data label values color, let's select white color, and I want to show them inside. Let's see if we have that option. Since I don't have that option, I will just use it like this. So we can see we have more FTL type of shipments here, or number of rows with FTL are more here. Now next is we have to learn histogram of start scan to end scan, or to find histogram of any particular numerical variable. Suppose you are using something like Tableau, so you have a particular type of graph in Tableau. But let me open a new page here and take start scan and end scan. So we will take a stack column chart which will represent our histogram. Histogram basically shows you distribution of data. So let's say you have starting range and end range. So you divide the starting range and end range into some bins or groups, and then on the basis of number of groups that you have created, you will see how many points do you have within each group or within each range that you have selected. So now on x-axis we will bring start scan to end scan, the particular variable that we are trying to analyze, and here we have the trip ID. So we will drag distinct count of ID, and you can see here. Okay, so start scan to end scan value that is given here. So from, you can see from start scan to end scan value of 72, the number of trips is 179, and we can see most of the values are within the start scan to end scan range of 0 to, let's say, 290 or 250 or 200, we can say, because here we can see most number of values. Now this is one way to create the data, but what we can also do, whatever variable you have that you have to use to compare this, you can compare this or create a histogram. So what you can do, you can simply click on these three dots and you can click on new group. When you will click on new group, you will see it will ask you to create bin type. So you can either decide on the basis of bin size, like this is from, because in your bin the minimum value is 20 and maximum value is 7898. We can also say we want total n number of bins. So let's say the total number of bins we want is 20. Let's click OK. Now we will again create the same graph, and here we are going to bring start scan to and scan bin here. Now you will see this new icon. That this icon represents a group here. Okay, that this is a group, same column, but we have created some bins here. And on y-axis we will bring trip ID, and now this is more easy to visualize, right? You can see we do have some values in the range of around 7500. Like we have one such value, that's why kind of an outlier, but most of the values are within the range of 0 to 20, and we have around 69,474 values. So total trip with a start scan to end scan, it in terms of bins, you can see the distribution. So in the data set that we have, this field typically represents the time duration, in our case in minutes, between the first scan of package at a logistic faculty start scan and its last scan as the same or subsequent faculty end scan. And this metric is often used to measure processing or handling time within a logistic network, and it can help analyze operational efficiency. And what we can do by applying the same style, we can copy or cut this visual from here and paste it in our main sheet or main page. I will simply reduce its height. I will try to fit more graphs here and if needed, but this is start scan to end scan. And what we can do, because we can see there is one outlier, right? There is one particular value here, only one value, and that is in the range of 7500. So if we keep everything below, let's say 4500, so we will be able to omit that outlier. And this is start scan to end scan value. So this is count of trip. So when you will click here, you will see all the filters applied to it. We are selecting all values, but we will say start scan to end scan value is show item when the value is less than 4500. Let's try to apply, and now we will have a better graph to visualize. So this is a simple metric that will help us in optimizing the overall efficiency. And first I will just adjust it. Now we have the data. Now as we compared OSRM versus actual time, we can also compare OSRM distance versus actual distance. Okay, so here we are going to use this, and suppose obviously we will simply click on it and go to format and send backward, so that our main graph is on top, and we will just adjust its height. In this particular chart we will do OSRM distance versus actual distance. We want to see what's the relationship between these two variables. So here I will remove these two and I will bring distance. So this is actual distance, OSRM distance, and segment OSRM distance. So we are going to bring the actual distance and OSRM distance and asking not to summarize. So you can see a fairly straight, increasing trend, that the distance between actual distance and OSRM distance, the relation is pretty much in a straight line. And we can simply change the title here OSRM versus actual distance. So this kind of tells us that the time predicted by OSRM will be helpful in predicting the actual time also. So, and obviously OSRM time is something that we know of, right? So it is a machine predicted time. So we will put it on x-axis, and actual time is something that we will put on y-axis. And in this type of graph, let's say we want to show our background also. So we can click it, go to General tab, and we can go to Effects. We have a background, so we will increase, its transparency to around 50 or maybe more. So that we can see the data as well as our background. So this is a simple way of analyzing that. And now we can fairly say that obviously in terms of time we have more you know scatter points, but in terms of distance prediction this will actually help us a lot. So in the data set we have OD start time and OD end time. The start time of the origin destination trip and the end time of the destination trip. So from any one of them we can get information about the date, because they are all in date hierarchy. So for example, uh, if we bring any one of them and try to create a simple line chart, so first of all we will click anywhere and click line chart. We will see whether area chart or line chart will be a better choice here. We are just creating. So here in our line chart on x-axis we will take any one of them. So start time, let's say as per the trip, and then we will see you know total number of trips in that particular period. And it looks like this data is of 1 year only. So in that case we can take month as our reference value, and you can see this is data of September and October. So that's why we will summarize it by date, and this way you can see on different dates in September you can see the information here, and in October we only have 1 or 2 dates here, so up to October 6. And you can also create a simple area chart here, and in area chart in legend you can bring a categorical column which is route type. So we'll be able to see, you can see most of the route types were full truckload from starting from September to the end date that we have in the data. So this is a start time that we have taken to visualize this. And I will try to just disable title for us, so that because it will be clear that this is date and this is route type. If I want to disable horizontal scrolling, I will just increase its size, and I will simply again, as I did earlier, I will go to background and increase its transparency, or disable background completely. We can also do that. Here also we have a background, we can disable that. We also have a visual border, we can disable that, and shadow also. Now there is one more thing. As we use legend here, here also you can use the route type as your uh, legend field to visualize distribution of start scan to end scan for different route types. So that is optional, but that will give us more insights into distribution of different route types. Now by just sending the image backward for right now, we have also created average actual time by day of week. We created the day of week earlier. You can see on Sunday, Thursday, Friday, and the average actual time is lesser on Saturdays. Okay, from here you can see that if you want to again use in this type of graph that we have used here is a clustered bar chart, and here also if you want to see for different route type, so we will simply bring it as a legend. So for example here I will simply bring it as a legend, and you will be able to see the average time for FTL and average time for carting. We can also do one more thing because we want to see them separately. So we will also use a slicer here. Okay. So because we also already almost have to see it in every case, like for FTL what is the performance, for carting what is the performance. So we can use a slicer here. I will position the slicer here, and slicer basically works as a filter. So I will just position it like this and reduce its height. Now I will simply enable its shadow. First we have to select field, otherwise it won't let us you know, customize. So first I will bring the root field here and go to visual, and I will disable the header. In general, if you want title you can say, but like root type for example, and we make it bold, not italic, bold. Center, choose the color, and this is pretty much it. If you want it like this, right, you can also enable some effects here like shadow, visual border, as we have done so far. We can also copy the same style, but let's say it will take less time here. Okay, now you can also show them as a button. So go to slicer setting and show as a tile. So now you will see them as a button. You can select carting, so you can see the entire data for carting, and you can see in case of carting we have some you know different type of values here, and in case of FTL we have almost the linear trend that we were seeing. So this way you can use them as a filter also, and the values that we are using we can increase their size, make them bold, and use a different type of font so that they are visible properly. Obviously because of space restriction we cannot change it too much. And now after doing all of this, we will simply bring back our image to its original position. I just have to make one more final change for this dashboard. Obviously there is a lot to analyze still, and we are also doing our research to understand various other parameters in the data set also, because it is something that will require some domain expertise like segment factors, segment OSRM. So another dashboard with these features will be created. But here I will simply go to effect and disable the background because we already have the data day wise. And now let's bring back our graph. So we almost have this part complete, and I have simply used sort axis here. So in this graph we have sort axis because actually Saturday is good because average time is less, right? So that's why you can sort accordingly as well. And after sorting you can see your filters and everything is working. Now because I just wanted to see the effect of this image in the chart, that's why I introduced it. It is totally not necessary, but this is the first part of our analysis of delivery or logistic data. In the next part, we will start with some more detailed analysis after digging more in the data set, and we will try to analyze it further. So please subscribe to our channel to receive the notification about that. Until then, thanks for watching this video. Have a nice day.